All right, because I blew your mind on 2.6. Here I am in computer science trying to help you out. All right? So we're doing related rates. And we're going to take rates with respect to t. But we're only given one variable, like in this example. The function is f of x equals x cubed minus 4x. But then we have dx dt equal to negative 2 centimeters per second, because that's a rate. It's changing. And we have dy, and we want to find dy dt. Well, if we're going to find dy dt, we say, all right, let's take the derivative with respect to t. I don't see any t's. So it's dy dt is equal to 3x squared. But since it's with respect to t, a different variable, we have to put, usually we would put x prime. Instead of x prime, we're going to graduate. And we're now going to put dx dt. So x prime is dx dt. Now, we're also going to do minus 4 dx dt. And all we got to do is now plug and chug. This now becomes just an arithmetic problem, because we have x right here. In our first problem, x is negative 3. So it's going to be 3 times negative 3 squared times dx dt. It was given to me as negative 2 centimeters per second. And also minus 4 times negative 2 centimeters per second. When the smoke clears here, looks like 27 times negative 2 is negative 54, and then plus 6, negative 48. Now, on my test on the AP exam, if you don't put the rate, you lose a point. Every free response question on the AP exam is 9 points. And you'll lose a point if you don't put the rates. So it's going to be negative 48 centimeters per second. All right? No problem. I'm going to let if you want to do the others, great. I'm now going to jump to what I did in class. And I said, given the volume of a sphere, find an equation, blah, 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 blah. This is not really what I did in class. Oh, where's the one I did in class? I don't know. Paul, that'd be at the end. That's fine. All right, here we go. We're back on. And now I want to tell you, here's an example. Suppose the lengths of a rectangular box are changing, x, y, and z. And that's just like anything. Here, if I open up any type of window, here's a window. If I do this, their sides are changing. All right? They're definitely changing. So that's what kind of I'm talking about. I have a rectangular box, and just the height's going up. Maybe something's decreasing. All right? And that's what I have here. dx dt, dy dt, dz dt, because it's x, y, z. Volume is length times width times height, which I'm going to change. I can't change the formula because it's been like that forever, but I could change it to the volume equal to x times y times z. How do we find a derivative with 3 variables being multiplied together? We really can't. We have to do some chain rulage. So it's going to be u equals, and I'll set 2 variables there, y, z. So du is now going to be first times derivative of the second, which is dz dt. Remember, everything is with respect to time, but we don't have a time variable. All right? Plus the second times the derivative of the first, dy dt. Now, wait a minute. I just replaced this with u. So now I got to take derivative again. So it's volume equals xu, and now it's going to be the first times derivative of the second, dv dt. The derivative with respect of volume with respect to time is equal to the first times the derivative of the second, which is du dt, all right, or times du, which is right over there in red, and then plus the second times the derivative of the first, dx dt. Now I'm going to replace everything that I need to replace. dv dt is equal to, I hope I can get this on the screen, x times this thing, this red thing right here. Get in there. Y dz dt plus z dy dt. All right? That takes care of this part. Now the other part is plus u, which is yz, times, and I have to come down here because I'm running out of room, times dx dt. All I got to do is plug and chug now. I have all the numbers for each one of these. All right? Plug them in, and I don't know what I get. I think, what did we get? Evan. All right, so when the smoke clears, okay, you're going to get dv dt equal to negative 46 centimeters. This is meters per second. We're still overseas. Meters per second. All right? So when you plug all the numbers in, that's what you'll get. You'll probably see it in class. Now the next part is the surface area. And if I wanted to see how the surface area is changing, I would say the derivative of the surface area with respect to time is, got to do the product rule here. So I'm going to do the first. Oh, I got to change these. L's will make X, Y, and Z. That's what we'll do here. So it's going to be first times derivative of the second plus the second times the derivative of the first. Derivative of 2x is times 2 dx dt. Then plus, if I multiplied that out, I'd get, there's an h outside, so I'd get 2, or z, 2xz plus 2zy. I always put a line through my z's because my 2's look the same. So now I'm taking the derivative. It's all product rule. First times the derivative of the second plus the second times the derivative of the first. That takes care of that one. And I have one more left. Plus the first times the derivative of the second plus the second times the derivative of the first. And if you plug everything in, you will get the magic number 0. Because take a look. When I'm moving things this way and this way, I don't change what the surface area was. I'm changing the volume, but the surface area is staying the same. Because if I stretch, if I had a rubber band that looked this big and I stretch it, the surface area is exactly the same. All right? It just looks thinner. Well, anyway, this is part 1, day 1. Your homework would be on page something. I don't remember. Let me see. Page 154, 2 to 8 even. Yeah, I know those 4 problems will kill you, but it's all right. They're not that hard. I want to thank publicly my computer science 7th period. Guys, let's hear it. Good job, guys. All right. I want to thank them. And oh, it's 6th period. This is for 7th. So 6. So they're angry with me now. So if they're angry, they have to tango. I thought we were going to have a tango lesson here. Or something. Get over here. Let's go. Let's go. This is them. This is all them. Right here.
Hi. We're Jake's not and I are going to take him. Okay. All right, let's go.
Go this way, because they don't see you that far.
Do you want to do a dip?
Yes.
You were going to do a dip.
I was going to spin you around. And I don't know how to tango, so. I'm like Bruno, like from Dancing with the Stars.
Takes 2.
Like Bruno.
Bruno.
That was intimidating, I tell you.